The National Electrical Code, or NEC, does address the reduction in size of the high-leg conductor. To understand this, let's delve into the specifics. Firstly, it is important to define what a high-leg conductor is. In a three-phase, four-wire delta system, one phase winding of the transformer is center-tapped. This center tap creates a neutral point. The phase leg opposite the center tap has a higher voltage to ground, usually around 208 volts, when the phase-to-phase voltage is 240 volts. This higher voltage leg is referred to as the high leg, stinger leg, wild leg, or red leg. Because of the potential for confusion and safety concerns, the NEC has specific requirements for identifying and handling this conductor. The high leg is often orange in color to visually distinguish it from the other phase conductors. Now, regarding the reduction in size, the NEC permits certain reductions in conductor size based on ampacity, which is the current carrying capacity of a conductor. The general rule is that conductors must be sized to carry the calculated load, and any applicable demand factors must be applied. However, there are exceptions and specific rules that allow for smaller conductors in certain situations. One such situation involves motor circuits. Article 430 of the NEC covers motor circuits and allows for conductor sizing based on the motor's full load current rating and applicable percentages. In some cases, this can result in conductors smaller than what would be required for general-purpose circuits. Another relevant area is the use of overcurrent protection. The NEC mandates that conductors be protected against overcurrent, typically by fuses or circuit breakers. The overcurrent protection device must be sized to protect the conductor's ampacity. If the calculated load is significantly lower than the conductor's ampacity, a smaller overcurrent device can be used. This smaller overcurrent device effectively limits the current that the conductor can carry, and in some cases may allow for a smaller conductor size to be used. It's crucial to remember that the NEC requires a minimum ampacity for service entrance conductors. For example, Article 230.42b specifies that the service entrance conductors shall have an ampacity not less than the maximum load to be served after the application of any demand factors. This requirement ensures that the service entrance conductors are adequately sized to handle the overall load of the building or structure. Furthermore, the NEC addresses neutral conductors and their sizing. In many cases, the neutral conductor is permitted to be smaller than the phase conductors, especially in services and feeders where the load is primarily nonlinear. Nonlinear loads, such as those from electronic equipment, generate harmonic currents. These harmonic currents can cause the neutral conductor to carry a significant amount of current, potentially requiring a larger neutral conductor than would be needed for linear loads. However, the NEC provides guidance on how to calculate the neutral load and determine the appropriate neutral conductor size. Section 220.61 outlines the requirements for calculating the neutral load in a service or feeder. This section takes into account the type of loads served, such as lighting, receptacles, and appliances. It also allows for demand factors to be applied to the neutral load, which can result in a smaller neutral conductor size. Regarding the high leg specifically, it's important to consult Article 215 and 230 for feed and service requirements, respectively. These articles provide the general rules for conductor sizing and overcurrent protection. While there isn't a specific section that explicitly allows for reducing the size of the high leg conductor compared to the other phase conductors under all circumstances, the general principles of ampacity, overcurrent protection, and load calculations still apply. The high leg conductor must be sized to carry the calculated load, and its ampacity must be protected by an appropriately sized overcurrent device. However, because the high leg is typically used for specific loads such as three-phase motors, the calculated load may be less than the overall service or feeder load. In such cases, the high leg conductor may be smaller than the other phase conductors. To determine if a reduction in size is permitted, a thorough load calculation is necessary. This calculation should take into account all connected loads, including motors, lighting, and receptacles. Demand factors should be applied where applicable, and the calculated load should be compared to the ampacity of the available conductors. the conductor must be protected by an overcurrent device that is sized to protect its ampacity, but not larger than the conductor's rating. It is also important to consider voltage drop. Voltage drop occurs when the voltage at the load is less than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for feeders and 5% for branch circuits. When sizing conductors, voltage drop should be taken into account. If a smaller conductor is chosen based on ampacity, it's important to verify that the voltage drop is within acceptable limits. If the voltage drop is excessive, a larger conductor may be required. Furthermore, the NEC requires that all electrical work be performed in a neat and workmanlike manner. This includes properly terminating conductors, labeling circuits, and ensuring that all equipment is installed according to the manufacturer's instructions. It's crucial to follow these requirements to ensure the safety and reliability of the electrical system. In addition to the NEC, local codes and regulations may also apply. These local codes may have additional requirements or restrictions that must be followed. It's important to check with the local electrical inspector to determine if there are any specific requirements in your area. When working with electrical systems, safety is paramount. Always energize circuits before working on them and use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. If you are not qualified to perform electrical work, it's best to hire a licensed electrician. They have the knowledge and experience to safely and properly install and maintain electrical systems. In summary, the NEC does address the reduction in size of the high-leg conductor indirectly through general rules of ampacity, overcurrent protection, and load calculations. While the NEC does not explicitly state that the high leg can be reduced in size compared to the other phase conductors in all situations, the principles outlined in the code allow for such a reduction if the calculated load and overcurrent protection requirements permit it. A thorough load calculation, consideration of voltage drop, and compliance with all applicable codes and regulations are essential to ensure the safety and reliability of the electrical system. Remember, it is always best to consult with a qualified electrical engineer or licensed electrician to ensure that your electrical system meets all applicable requirements and is installed safely. Understanding the National Electrical Code is crucial for anyone involved in electrical work. The NEC provides a comprehensive set of rules and guidelines for the safe installation and maintenance of electrical systems. By following the NEC, you can help to prevent electrical hazards and ensure the safety of people and property. The NEC is updated every 3 years, so it's important to stay current with the latest edition. Changes and revisions are made to the code based on new technologies, industry best practices, and safety concerns. By staying informed about the latest changes, you can ensure that your electrical work is always up to code. Additionally, consider the practical aspects of conductor selection. Factors such as ease of installation, availability of materials, and cost can also influence your decision. While it's important to comply with the NEC and other applicable codes, it's also important to choose conductors that are practical and cost-effective for your specific application. Consider the environmental conditions in which the conductors will be installed. Conductors installed in wet or corrosive environments may require special insulation or protection. The NEC provides guidance on selecting conductors for different environmental conditions. For example, conductors installed in underground conduits may need to be rated for wet locations. Furthermore, consider the type of equipment that will be connected to the conductors. Some equipment may have specific requirements for conductor size or type. For example, some motors may require conductors with a high temperature rating. It's important to consult the equipment manufacturer's instructions to determine the appropriate conductor size and type. In addition to conductor sizing, consider the type of insulation used on the conductors. The NEC recognizes different types of insulation, each with its own specific properties. The type of insulation affects the conductor's ampacity, temperature rating, and resistance to moisture and chemicals. Choose the appropriate insulation type based on the environmental conditions and the type of equipment that will be connected to the conductors. Proper grounding and bonding are also essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, which helps to trip the overcurrent protection device and prevent electrical shock. Bonding connects all metal parts of the electrical system together, which helps to equalize the voltage and reduce the risk of electrical shock. The NEC provides detailed requirements for grounding and bonding. Following these requirements is crucial for ensuring the safety of the electrical system. In conclusion, the decision to reduce the size of the high-leg conductor in a three-phase, four-wire delta system is a complex one that requires careful consideration of the NEC local codes and engineering principles. While the NEC does not explicitly prohibit reducing the size of the high-leg conductor, it does require that the conductor be sized to carry the calculated load and be protected by an appropriately sized overcurrent device. A thorough load calculation, consideration of voltage drop, and compliance with all applicable codes and regulations are essential to ensure the safety and reliability of the electrical system. Always consult with a qualified electrical engineer or licensed electrician to ensure that your electrical system meets all applicable requirements and is installed safely. By understanding the NEC and following best practices, you can help to prevent electrical hazards and ensure the safety of people and property.